सर आप बोल रहे हैं, आपकी आवाज़ नहीं आ रही।
हेलो। हेलो मारिया, आवाज आ रही है?
सर अब आ रही है आवाज़।
ऑलराइट। Okay, so we're talking about RS-232. These are some physical details of the RS-232 signal, where 2, 3, and 5 are ground, receive and transmit data, as we talked about. And DTR is data terminal ready. These are other are for the modem. If you have an external modem that you want to connect to your PC. The idea was this is designed for older days when there was a separate modem. Uh, and the one side of the modem you could connect a telephone line and with the telephone jack, and the other side of the modem you could connect the computer using RS-232 interface. So uh, now we have Wi-Fi, but that wasn't the case in 90s, 80s, and late 80s and early 90s. So you had to have a modem. Uh, so this interface is complete to communicate with the modem. But when you want to talk about with the microcontrollers and talking, communication between microcontrollers, you don't use the modem controls. So you just need pin number 2, 3, and 5, RX, TX, and ground. And if you're taking them from RS-232, you have to convert them from -12 plus 12 to 0 and plus 5. That is very important. Otherwise, your microcontroller will be destroyed. -12 is not something you can apply to any pin of the microcontroller. So this is the block diagram of this uh, very simple block diagram of the serial port. Uh, so these are basically all those two shift registers that we were talking about. One is a receiving shift register and other is the transmitting shift register. So receive clock is this over here and transmit clock is this over here. So these are clocks are locally generated when it is decided that this will be the speed of the data transmission. So these are some controls. This is a receive buffer, this is a transmit buffer, and this is called SBUF in higher languages, serial buffer. And the UART 16550 is very, very popular IC. And you don't have to buy this separate IC. What you do is you buy the IP of this IC. So then you can insert all the design of this IC inside another IC. So that is called IP, intellectual property. So you don't buy another UART IC to connect to your microcontroller IC, you can ask the UART, this company to sell you an IP. IP is basically the IC manufacturing information that you can actually embed in your other IC design that you already have. So it's kind of, becomes an ASIC, application specific integrated circuit. So you have not everything that is inside a big IC is designed by one company. So companies buy some peripheral stuff from other companies and they make that, embed that into their own IC. So that that is called IP. Then you have to report to the company that I have made so many ICs, and according to those ICs, you have to give them uh, money or what do you call it, royalty for that how many ICs you make. They don't do nothing. They don't produce anything. They don't make anything. They don't make any IC. All they are telling you is that this is the information. And put that IC design information inside your big IC. So your big IC will have, it's one single IC will also have this information embedded in your IC. So that way you can buy IPs and for various things that you can actually connect with your uh, processor. So this IP is basically UART 16550. Mhm. So this standard we have already talked about, and we already talked about these rights. Uh, and there is another thing that is called 20 milliampere current loop. That is exactly the same standard as serial port, but data is transmitted over a current loop of 20 milliampere. So mm, basically, you have a current source on the transmitter side that has 20 milliampere current. So it can have zero current or 20 milliampere current. On the receiving side, all you need is a resistance of 250 ohm. So 20 milliampere multiplied by 250 ohm, what do you get? Anybody? What do you get? 20 milliampere multiplied by 250 ohm.
So 5 volts?
5 volts. Very good. So when this switch is on, the receiver side gets 5 volt. When switch is off, the receiver side gets 0 volt. So, what is the advantage of this? That if this current current loop is quite ideal, then the length of the wire doesn't matter. The wire resistance can be overcome because this current loop makes sure that the 20 milliampere current flows, and on the receiving side, the resistance of 250 ohm will always get a 5 volt, no matter how long is this wire. An ideal current source really can provide, very well infinite resistance if you talk about ideal, but non-ideal, nearly ideal would have very, very high resistance. Practically, there is a limit that how much resistance can be there before this ideality of this ideal current source is lost. It cannot be ideal. That is not possible for all kind of infinite distance of the wires. So there is a length. So between the buildings in a factory and when the factory has far, far away buildings and there is only one control inside one office of everything, then you need these 20 milliampere current loops because they provide very high accuracy of data. And many, you go in the market, you'll find many commercially available sensors and relays, commercial level. Uh, they have this 20 milliampere output standard. So that provides very high efficiency. Also, one very important thing about this high uh, current loop is that it can provide optical isolation like this over here. So this is an optical isolator. Optocoupler is also called optocoupler. So all the long distance communication where through wires, not RF or radio, must have this RF coupled, RF isolator between them. So why the reason is very interesting for this. Why do we need RF these optocouplers? Industrial design, you need these optocouplers. Reason is that let me explain. करना यार जरा वीडियो स्टॉप शेयर कर दिया करो. That if you have a building here, say M7, and you have a building here, say library building. So if you transmit normal transmission TX, RX, and RX and ground. So that means you have to common these two grounds together. So usually this ground is also earth. So it is connected to the ground of the building also, which is earth. Wabda has every neutral point connected to earth on its every uh, पोल. हर खंबे पे ये किया होता है उन्होंने, खंबे को अर्थ किया होता है उन्होंने ताकि लोगों को करंट ना लगे. So this library building and this, so this is okay, no problem. There is no problem if this is also earth, and earth and ground are short circuit, no problem. The only problem can occur when there is a light that strikes on this light arrestor that is on top of the building. Lightning को जो arrest करता है, तो बिल्डिंग शॉर्ट सर्किट करंट इधर से इधर को फ्लो करती है. When that happens, this this whole of this ground area of this library building will become for a very small time very high voltage, 30 kilovolt or many megavolt or something like that. तो zoom कर दो थोड़ा सा. So what will happen then? This is ground. This is 30 kilovolt or something like. So within ground terminals, very very high current flows. इधर कुछ नहीं होता क्योंकि फर्स्ट फ्लोर में और टॉप फ्लोर में आपस में, तो सारे टॉप फ्लोर में आपस में कोई ग्रेविटी डिफरेंस नहीं है, पोटेंशियल ग्रेविटी डिफरेंस नहीं है. इस बिल्डिंग में मैं टॉप फ्लोर पे चले जाऊं तो जो सारे लोग टॉप फ्लोर पे हैं वो सारे टॉप फ्लोर पे हैं, वी आर ऑन द सेम पोटेंशियल. Same case here. Everything in this building stays at the same potential. So there is no current flow between this building. Only when it comes to very long distance wires, this problem can occur. Then this lightning can cause another current flow in this direction. So, so if this and then this is so huge current, I have personally seen, I see literally the whole of the system is black, काला हो जाता है if you have no isolation here. This is a huge design problem. This is not simple. तो अगर टेलीफोन एक्सचेंज की छत पे अगर बिजली है, अगर you don't have any control there, what happens is that all the people who are connected to the telephone exchange building, they get a huge surge of current that destroys everything. So that's why this is there, that optical isolator is always there. This optical isolator is always used also when you want to control some motor, high speed motor. So motor has very high voltage levels that can feed back into the this side of the signal if you don't have a optical isolation. So you will use a phototransistor with this. This is called optical isolation. है हमारे पास यार ये पड़ा हुआ आईसी जिसके अंदर ऑप्टो कपलर होता है, लेके आना है। So this optocoupler. So when the light of this LED, this whole stuff is basically inside an IC like, but inside there is a chamber. External light cannot disturb this. When this LED light is illuminated, the light falls on the base of this transistor and transistor turns on. You can say that this is turned on. So as a result, current can flow over here and you can send signal. So transistor can be off or transistor can be on. Now these two are electrically isolated. This this is called analog ground, because here can be any high voltage levels. It can be a relay here or some other very high voltage level signal. This shouldn't be 5 volt. This can be 12 volt, 30 volt, 64, whatever it is. But this side stays isolated from this, and this is called digital ground. So these analog ground and digital ground are different from each other. And they are isolated from each other. So many ICs. हाँ वही होगा ये so this is one of those ICs there. लगाना यार इसके आगे करना है, जूम नहीं होएगा ना, वो फोकस खराब किया हुआ। यहाँ से बंद करके ठीक होगा, रहने दो। हाँ this is a small looking thing over here, four pins attached to it. Right. बस ठीक है, काफी सही है। So this is what provides optical isolation. A very important component in practical electronics. Very important component. So let's go back to our slides over here. So this is the part of this over here. Many motor drivers you buy, they specify that they input digital inputs or PWM inputs that control this transistor have optical isolation. Inside you could have a PWM signal. This side you could have this transistor, but optically coupled. So the motor side, which is the high voltage side, they have no electrical connection to this. Very important. So let's talk about a second type of protocol, and that is synchronous communication protocol. Uh, in synchronous communication, you need to send the clock also. When you send the clock, basically then the data speed can be very high. Data speed can be very high because clock makes sure that the signal is uh, every data is clocked on the other end at the right time. अगर ट्रांसमिशन वाला ये चूंकि क्लॉक भी सेंड कर रहा है तो रिसीवर को कोई मसला नहीं है इट कैन रिसीव डाटा automatically with the clock. So in that case, you just don't have to have send a byte of data. You basically send a block of characters called uh, a frame or a packet. So you can send a complete frame of data. And now the question is, do you send a separate wire for clock? That's the big $100 million question. You send a separate wire for clock? Answer to that is no. The clock is basically embedded within the data. No. This happens uh, because of this circuit, the phase lock loop, PLL. So PLL plays a very important role in this serial communication, synchronous serial communication. So what is PLL? Uh, so what is PLL? PLL is basically this circuit here, where you have an input signal. नजर आ रहा है आप लोगों को? उमैर, can you see?
जी सर, जी सर.
So basically, you have an input signal here, and you have a phase comparator. If there is a, and you have a local voltage controlled oscillator, VCO, voltage controlled oscillator. Basically, if this voltage is zero, it has some F naught frequency, center frequency, and it can go low and high above that center frequency oscillation. So, for example, if you are sending a 1 megahertz signal here, 1 megabits per second signal, so here you have this can be 1 megabit plus minus few hertz up and down. So if what it does is that first it matches the phase of this output to the phase of this input. So if there are difference, there is a difference, there will be a error voltage here. And that error voltage is amplified and that then go through the VCO. VCO adjusts its voltage so that output oscillation so that they are become both in phase. Definitely they cannot be in phase until they are in same frequency is also there. So in phasing includes frequency also. So right before you start, there is some time before it catch this voltage oscillator catches to this input clock. So this that way this output is taken from here and this output is basically the same clock signal as this is coming over here. Now you the question may be कि why not use the same input clock? Why are you generating an output clock here? Why are you generating a separate output clock? The answer to that is you probably will not find easily in some books. सारे ये तो कहते हैं कि फेज लॉक लूप ये करता है, लेकिन maybe I am wrong, but this is what I think it is. That this is PLL, so it generates its own clock which matches this in clock out, and this is a clock in. So it is basically data which has a clock embedded in it. We'll talk about that later. How is that embedded in it? So clock in and clock out. So if these are the both same clock in, you may say, okay, why not use this? Why are we using this? So anybody can answer that? Can anybody answer that? आज तो बहुत लोग कम लोग क्यों आए हैं इतने भाई? Only 5 people here. Why?
सर मिड टर्म
कब?
2 बजे।
Oh, I see. आप लोगों की यार बड़ी हिम्मत है, आप लोग बैठे हुए हैं। कौन सा मिड टर्म है?
कम्युनिकेशन सिस्टम्स।
ओह अच्छा अच्छा अच्छा, तो आप पहले ही बता देते यार, हम आज की क्लास का कुछ कर लेते। लेकिन चलो कोई नहीं, रिकॉर्ड हो जाएगी इसी बहाने और लोग देख लेंगे। So PLL, what is this output? The answer to that is that this clock in, if it starts sending data for a very long time, this clock will stay the same. It's only after a particular time that this will start to diverge from this clock. ये यूं समझ लें कि एक ट्रेन गाड़ी है जिसको आप दो लाइनों के बीच में चला रहे हैं, तो अगर गाड़ी थोड़ा सा उसका जो है ना, वो जैसा अक्सर बसें होती हैं या गाड़ी होती हैं, थोड़ी सी कन्नी खा रही है, थोड़ा सा एक तरफ जाने की कोशिश कर रही है, तो क्या होगा? आप उसको अगर छोड़ देते हैं थोड़ी देर के लिए, वो बिल्कुल लाइन के एज पे जाने की कोशिश करेगी, आप फिर उसको सीधा कर देते हैं, फिर थोड़ी दूर जाते हैं, देन इट रेन ट्राइज टू क्रॉस द अदर साइड ऑफ द लेन, so go tries to go into the other lane, so you adjust it again, so that way you always stay in the lane, unless you kind of get some sixth sense जो ड्राइवर्स की होती है, वो जो ये खास जगह पे एडजस्ट कर लेते हैं, फिर वो एडजस्टिंग नहीं करनी पड़ती, बट इफ यू डोंट डू दैट, this is what happens, you start to diverge. This is the clock in, ये इसकी क्लॉक आउट है, ये विद इन सर्टन टॉलरेंस लेवल के अंदर अंदर ये इसको फॉलो करती रहती है। जो ही ये आउट ऑफ फेज जाने की कोशिश करती है, ये पीछे से क्लॉक आ जाती है जो इसको फिर ठीक कर देती है। सो इट हैज टू बी लाइक दिस, दैट द क्लॉक शुड कम इन आफ्टर सम टाइम, कि इसका किबला दुरुस्त हो जाए। सो तो वो थोड़ी सी वेरिएशन आती है जिससे कि रिसीविंग डाटा पे कोई फर्क नहीं पड़ता। So that's really, these PLLs are it's engineering has some really some great miracles, and every day we talk about them. A PLL is a solved problem. It is used everywhere, everywhere, and some I can talk about this. This there was a whole workshop on phase lock loop offered here a couple of last year, a couple of years ago, a 5-day workshop on phase lock loops, their uses, and this one interesting loop of phase lock loop is that you have say clock in क्रिस्टल की क्लॉक है 8 मेगाहर्ट्ज आपके प्रोसेसर में in your PIC you have a PLL. So there is an oscillator of 32 megahertz. And then this output can run this processor at 4 times the speed of the crystal. But how is this uh, always maintained? And it has to be very accurate. Otherwise, your timers will not be able to operate. So there is a 32 megahertz oscillator, which is voltage controlled oscillator. Now, how is this synchronized with this? You have a counter which divides this by 4. So you get 8 megahertz output. Between this 8 megahertz and this 8 megahertz, you have a phase lock loop. So error voltage goes to this 32 megahertz voltage. So that way this 8 megahertz always is trying to follow this 8 megahertz. So internal oscillator then always follows this crystal frequency. So your PIC microcontroller also has 32 megahertz. So basically if you use 16 megahertz processor, you can make your processor run at 64 megahertz, which is very high speed. So this is a very interesting. There are so many uses of VCO. Is just voltage controlled oscillator and these PLLs is unbelievable, unbelievable. The communication and everything wouldn't have been same if there were not PLL, phase lock loop. So they play very important role. So coming back to our shared screen. So this is the role of the PLL circuit. Basically, every time I see come to understand this circuit, I marvel at the people who have actually got us to where we are today. There are lots of highly intellectual input into this electrical engineering systems. Highly intellectual, and so PLL plays very important role. You would study that in communication course probably. पढ़ लिया आपने communication में PLL उमैर?
नहीं सर, अभी नहीं.
So this job of this is to receive the current. So standard I will talk about. The serial communication standards are HDLC, high level data link control, which is used by Ethernet, which is used by Wi-Fi, which is used by everything. Many things they use the same, HDLC. So there's some uh, differences over here. SDLC was the beginning. We had SDLC, synchronous data link control system, and now we have HDLC, high level data link. Uh, so in this you can send data in frames. We'll talk about those frames. I just want to highlight how the clock is embedded in this. One very popular way of sending clock is non-return to zero, invert, NRZI. So that basically is that if you want to send a zero, you send that by an edge in the transmission. So whenever a zero is to be sent, you send, so for example, you want to send a zero, is there a change? If you want to send one, no change. You want to send one, no change. When you want to send zero, change. You want to send a zero, change. When you want to send one, no change. So when you don't send anything, what are you sending? You are sending a string of zeros. When you don't send anything, what are you sending? You send a string of zeros. That zeros are changing on every bit. So that basically generate a clock. So you just stop sending. You don't have to do anything. You just stop sending any one bit. Just send a long string of zeros, and that automatically generates a clock. And the receiver PLL can again synchronize with the remote clock. The local clock then can be, you know, synchronized with the remote control. So if you are sending just a long string of zeros, what you are sending is a clock. अगर ये भी जीरो होता तो इसने नीचे चला जाना था, ये भी जीरो होता इसने ऊपर चला जाना था. So if you see, if you have long string of zeros, what you are sending is clock. So after some time, you just send nothing. The receiver side will get a clock. So that was very easy to send. तो मेरा ख्याल आज के लिए इतना ही काफ़ी है. You have a 2 o'clock. You have a communication. So just this NRZ is where we end today. Non-return to zero invert. ठीक है. तो बस 2-3 स्लाइड और रह गई हैं. We'll talk about them later next class. This is NRZ. Do you study this NRZ in communication also? मैंने आपको सिंपल सी उसकी एक चीज बता दी है कि वो ये कि जब when you are sending nothing, you are sending clock, and that clock helps synchronize the PLL on the remote side. So PLL never really runs, never really runs away. Run away नहीं होता उसमें. It always gets synchronized with the remote clock. Okay. So thank you very much. I think we can end it today.